Lesson 79 is about something called piecewise functions. So imagine you were to go to the Nashville Zoo and look at their ticket prices. I think this is weekend prices. They might tell you something like, well, adult tickets are $25. Children, which are the ages of 2 to 12, cost $21, but if you're under 2, you're free. Okay, so this is actually an example of a piecewise function. So if you had to write what this would look like in function notation, and write f of x equals, okay, well, there isn't just one function, or you can just write one rule for it. You actually have to write different rules based on what the input x is. So if x is greater than 12, then that counts as an adult. And then when I put numbers like that in, then the value will be $25. Okay, if on the other hand, I have an x value and it's greater than or equal to 2, but less than or equal to 12, that's what the child ages are, and that would be $21. And if you happen to have a child and the age is less than 2, then it would be 0. It would be free. Okay, so there's 3 different rules about how you compute, and when I take and put all 3 of those rules together, that defines how to evaluate the function over the entire, and we might even want to say if x is between 0, is greater than 0 and less than 2, because, you know, clearly it doesn't make any sense for us to try to write something for a child or an age of -17. Like, nobody can be 17. So in particular, if we looked at this, the domain of this function could be values that are greater than 0. Nobody, okay, you know, once you're born, okay, I guess the very actual moment you're born, I guess you're 0, but like 1 second goes past and you're already more than 0. So we'll say that you can't be exactly 0. I guess perhaps you could be. If you want to put an equal in there, I don't think I would argue with you. Okay, and then the range for this particular function, okay, you can only get out 3 particular y values. You can get out 0, 21, or 25. There is nothing in between those values. Okay, so a piecewise function is simply a function that's comprised of at least 2 functions. In this case, we had 3, but we need at least 2 for it to be piecewise. And then each individual function that you have defines a different part of the function's domain. So here, the domain of our function f of x is all real numbers that are greater than 0. But we've divided the domain into different parts. So part of the domain is between 0 and less than 2. Part of the domain is from 2 to 12 inclusive, and part of the domain are ages that are greater than 12. So we've divided up the domain into different parts, and we've made a different rule for each part of the domain. Okay, and so that is what a piecewise function is. Let's look at how you might go ahead and graph that function. So if, let's say I wanted to graph that function, I'll see if I can fit it right here. Okay. Let's see, let's count by 5. So this is like 5, 10, 15, 20, 25, and I'll do ages here. We'll also count by 5s, I guess. 5, 10, 15, 20, 25. Okay, so these are the ages, x, and this is the price in money. Okay. And so we know if the person is from 0 to 2, the amount is 0. So let's say this is 1, 2, 3, 4, 5. Okay, so here's 2 right here. Okay, so if they're strictly less than 2, I think I might have to go with a finer grain marker here. Okay, I would put an open circle around 2 because it's not equal to 2. And for mine, I'll put an open circle on 0. Okay. And then for any age between 0 and 2, the amount of money I have to spend is $0. Okay, so that's that part. Okay, now once we get up to 2, it's going to cost $21. So at 2, it's going to be $21. Okay, and it continues to be $21 if you're 2 years in 1 day, 2 years in 3 days, 2 years in 3 days and 14 seconds, like no matter what, all the way up until you get to 12. Okay, so let's say that's 12 right there. That's also $21. So anything from 2 to 12 is $21. Okay, and then once you get above 12, I'm going to say greater than or equal. Yeah, ages are tricky things here. This is kind of like what happens if you're 12 years and 13 seconds. We still call that 12. So I'm going to put actually up here greater than or equal to 13. Okay. And so if we do it that way, actually right up until you're 13, you're going to have to pay $21. But once you get to be 13, you got to go to 25. And then from then on, and we don't have really an upper limit on what your age is. Okay. And I'll put this one if you're less than 13, strictly less than 13. Anything less than 13, we'll consider that to be 12. Okay. That was a better way to write the zoo's price structure. Okay, so anywhere up to 13 is going to be $21, and then 13 and older is going to be $25. Okay, so that is an example. So if you see this is definitely a discontinuous kind of graph, I have to pick my pencil up to get from one part of the graph to the next part of the graph to the next part of the graph. So this is definitely a discontinuous function, but it is indeed a function. If I put a vertical line anywhere, it only crosses the graph at one point. Now this kind of function where I have this straight line and then another straight line and then another straight line like this horizontal straight lines in particular, is a special kind of function, a step function called piecewise function called a step function. So a step function is a piecewise function that is constant for each interval on its domain. So notice, okay, every time I define the function, there's a constant value here, like 12, -5, 2, for each interval of its domain. Okay, and so f of x equals 12 is a horizontal line. F of x equals -5 is a horizontal line. F of x equals 2 is a horizontal line. So it's going to look like portions of horizontal lines just like this last one did. So I had a part of a horizontal line, part of the horizontal line, f of x equals 0. Okay, the next interval I have part of the horizontal line, f of x equals 21. And then the last one I have part of the horizontal line, f of x equals 25. So that's an example of a step function. This is an example of a step function. Okay, so let's say that I have these various step functions here, and I want to write a piecewise function that describes these graphs. So let's look at some examples here. So let's call this one f of x, let's call this one g of x, let's call this one h of x. Okay, so here f of x, it looks like it's got 1, 2, 3 different rules. Okay, so the first rule, I'm just going to go from left to right, tells me about what it is when the x values are less than 0, right? So there's an open circle here. So it's not when it's equal to 0, but when it's less than 0, I'm always going to have the value -1. Okay, so -1 is my first value here, and that will happen as long as x is a value that's less than 0. Okay. And then my next portion is this one, but it's just a single point here. Okay, so this only happens when x is equal to 0. Okay, so the value will be 0 when x equals 0. Okay, and then this portion, okay, is when the x values are greater than 0. So if x is greater than 0, okay, that will be +1. So that's what that piecewise function would look like. Let's look at g of x. Okay, so moving from left to right, okay, the smallest value that we have defined is at x equals -4. And all x values between -4 and -2 are exactly the same. They all give us the value of 4. So it's going to be 4 when x is greater than or equal to -4 and less than or equal to -2. Okay. Then between -2 and 2, now it can't be equal to those, but between -2 and +2, not equal to, but just strictly between them, okay, then we have the value 2. And then the next interval is when x goes from 2 up to 4 inclusive. Okay, so from 2, including 2, all the way up to and floor, including 4, and those values will be -3. Okay, and then the last one, h of x. Okay, again, going left to right, the smallest value we see defined would be -4. Okay, and it is equal to that. And then that value will continue up until we reach -1, but not at -1. So that would have to be strictly less than -1. And that value is at -1. Okay, now when we reach 1, x equals 1, we get something new. So from -1 equal all the way up until x equals 2, we have a new value, and that value is 2. Okay, and then after 2, so x would have to be greater than 2, and then all the way up until it equals 5. So greater than 2, but less than or equal to 5. Okay, we're back down at -1. Okay, so we could write it that way. The other thing we could do is, since this value and this value are the same, we could put this or 2 and take out this rule altogether. Okay, so either way would be an acceptable way. If you don't want to write extra lines, you can say on this interval or on this interval it would be -1. Okay. Okay, so that's how you would go about writing. Let's go ahead and look at how you might go about graphing. Going to be some blank paper here so we don't have this background. All right, so here's another example. It said we wanted to graph a piecewise function, and it was this particular rule. So f of x is x squared minus 1 when x is less than or equal to 0. It's 2x minus 1 when x is between 0 and 5, okay, including 5, but bigger than 0. And then after 5, it's the constant 3. Okay, so looking at this one is x squared minus 1 is a parabola. Now, I'm going to go ahead and pencil in like the entire parabola, and then I'll write over top of that with the part that's actually just part of our graph. But imagine if we had to graph the parabola x squared minus 1, that's a parabola that this minus 1 shifts it down 1 unit. Okay, so it would be down here, and then it would go here, and here, and then all right. And so it would look, you know, if I were to put in all the points on the parabola and lightly pencil it in, the parabola would look like this. Okay. Now, we're not going to have the whole parabola. So I kind of penciled that in lightly, but we're not going to have the whole thing. We're only going to have that parabola for the values that are less than or equal to 0. So if I'm going, my x value is less than or equal to 0, I'm moving here, okay, and as soon as I get to 0, I stop. And the rest of it is not going to be a parabola. The rest of it's going to be something else. Okay, so the only part of the parabola that I'm getting is this part of it. Okay, and nothing else. We're just getting that portion of the parabola, so I'm going to erase it. The rest of it is not part of my function. Okay, then from 0 all the way up to 5, it looks like, well, this graph looks like a line, 2x minus 1. Okay, and it would have a y-intercept of -1, and then it would have a slope of 2. So it would rise 2 and run 1, rise 2 and run 1, rise 2 and run 1. So if I drew the whole line, it would look like that, right? Clearly, I'm not going to have any of this part that's down here. So it's going to go from after 0 up until it gets to 5. So here's 1, 2, 3, 4, 5. Here's 5. Okay, so that portion. And then after that, it just looks like 3. Okay, so here's 1, 2, 3. Here's 3. Okay, so from 5 on, it looks like that. So not at 5. At 5, it's up here. We're using this rule. Okay, so not at 5. I'm going to put a little hole there. But anywhere after 5, it looks like 3. So it'll keep on going in that direction. Okay, so that's what the graph would look like. It's sort of a parabola up until it reaches the y-axis. Then it's this line with slope 2. Up until 5, and then after 5, it's a horizontal line at 3. So that's what the graph looks like. All right, and now let's say that we had to evaluate. Well, let's answer this question. So, is this actually a function? So I could put a vertical line. It's always the vertical line only touches the graph once, even here. Okay, notice if I were to draw a vertical line through x equals 5. Okay, it's only touching it once because this is a hole. Okay, it touches it here, but it does not touch it down here. So it touches it on this line, but not on this horizontal line. So it is indeed a function. And let's say we wanted to find out what f of -2 is. So we look at the input, -2, and we would go check which interval it falls into. Is -2 less than 0? Yes, it is less than 0, so we would use this rule. Okay, so we're using this rule, so it would be -2 squared minus 1, which is 3. And let's look at our graph. If I went to -2, 1, 2, 3, sure enough, that's the point that I put on my graph. Okay, f of 0, okay, I would just go through the intervals and check which one it evaluates to true. So is 0 less than or equal to 0? Yes, it is. Okay, it's equal to 0. So again, we would be using this rule, and we would get 0 squared minus 1, which is -1. So 0, -1, sure enough, that's the point on our graph. And then f of 5, okay, so we would go through the intervals. Is 5 less than or equal to 0? No, it's not. Is 5 greater than 0 and less than or equal to 0? Yes, it is. So this is the rule we would use. And the value would be 2 times 5 minus 1, which equals 9. And so 5, 9 Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's where it should be, right there, is indeed the point that's on our graph. Okay, and if we wanted to add another one, like f of 7, okay, I'd have to go through the rules and go, is 7 less than or equal to 0? No. Is 7 greater than 0 and less than or equal to 5? No. Is 7 greater than 5? Yes. So we would be using this rule, and f of 7 would be 3. And so if we went out to x equals 7, the point 7, 3 would be on our graph. Sure enough, it is. Okay. Okay. And the last thing that we want to do is look about what if we had a word problem like lesson practice E. This is on page 560 of your textbook. Let's say we have this and we need to write a piecewise function for the cost of something for this particular word problem. So we have a plumber that charges $50 per hour for the first 3 hours and then $25 an hour after that. And we need to write and graph a piecewise function for the cost of x hours of service. So let's call our function c of x, so the cost for x hours of service. Okay, and we see that the rule is different depending on whether the number of hours is within the first 3 or if it's after that. Okay, and so we're going to have one rule for x being less than or equal to 3. Okay, and let's go ahead and say that it's down to 0. We can't work negative hours. I suppose he could work 0 hours. I don't know why you would call a plumber to come work 0 hours for you, but we'll go ahead and put 0 in there. And then after, so if it's more than 3 hours, a new rule is going to be applied. Okay. And so if it's anywhere up to 3 hours, it's going to be $50 per hour. So we know that it's going to be $50 times the number of hours, 50 times x. Okay. Now what happens after that is the plumber is going to start charging $25 an hour after that. Now it's really tempting. What students want to do is come in here and write 25x. Say, oh, it's going to be $25 an hour. Okay, let's think about why that is wrong. So let's say that I had 4. If the plumber worked 4 hours. And if I had 25x here, and it was 4 times 25 is 100. Okay. Here, for 3 hours, it would charge $150. So do you think the plumber is going to charge $150 for 3 hours, but $100 for 4 hours? That doesn't really make sense, does it? No, it doesn't. Okay, so for the first 3 hours, he's still charging $150. But then anything above and beyond, so if it's 3.1 hours or 3.01, anything over 3 is going to, the price is going to go down. Okay, but those first 3 hours are still going to cost $150. So we're going to have $150 for the first 3 hours, and then we're going to add on $25 an hour for any hours that are over and above 3. So how do we figure out, okay, extra hours that are over and above 3? Well, we're going to take the number of hours and subtract 3. Okay, and so if the plumber worked for 4 hours, he would charge $150 for the first 3 hours, and then for that additional hour, it would only be $25, and so it would be $175 for 4 hours, and then $150 for 3 hours, and that makes a lot more sense. Okay, so when you have problems like this in your homework, really resist the temptation of thinking that you can just do 25x on the second one. These are additional hours above and beyond, okay, the first set of hours. All right, so there, now that we have a nice function, we can go ahead and graph it. Okay, so let's say here is going to be 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, and so on and so forth. And then our cost, let's count maybe by 25s. So okay, so this would be 25, 50, 75, 100, 125, 150, 175, 200, 225, and so on and so forth it goes. Okay, so anywhere from 0 to 3 is just going to charge $50 an hour. And so for 1 hour it would be $50. For 2 hours, 2 hours would be $100. For 3 hours it would be $150. And so in general you're going to just get this linear kind of thing here, and I'll put closed circles on those because of the equals. And then after that, we're going to, instead of having a rate of $50 per hour, we're going to get only a rate of $25 per hour. So you can see that in one more hour, it's only the price is only going to go up by $25. And then in another hour after that, it's only going to go up another $25. Okay, so the rate changes, and it's going up at a different rate after the 3. Okay, still it's going up in a linear rate, just a little bit slightly slower. Okay, so that's what the graph would look like for the plumber's service charge.